evening, and thank you for joining us for another edition of Within the Circle broadcast. I am your host, Dr. Shaneke Campbell. Within today's program, we'll be talking about the comparative study of COVID-19 variants. Joining us on our panel of discussion, we have Dr. Tiffany Bassier from Mayo Foundation for Medical Education Research, Dr. Javine Hines from CDC, Center of Disease Control Prevention, Dr. Tashima Williams-Benton from WHO, World Health Organization, Dr. Christine Richards from CDC, microbiologist Tamika Clark from CDC, and microbiologist Daisy Smith from CDC. Hello, welcome, and thank you for joining us. We are just going to jump straight into our discussion. We know that the coronavirus is a large family of viruses that cause illness from the common cold to severe disease. So Dr. Tiffany Bassier, what can you tell us? Give us a brief summary of what the coronavirus is, what are the variants, and what is a variant?
Hello everyone, and thank you Dr. Campbell for having me today. So let's get straight into our discussion. What is the coronavirus? The coronavirus is an infectious disease that is caused by SARS-CoV-2 virus. We also know that the coronavirus has many variants. These variants come about when the virus replicates. We know that viruses replicate. So when they replicate, sometimes they undergo changes, genetic changes that we refer to as mutations. Now, when the virus has two or more new mutation, we refer to those as variants of the original virus. Now, some of the variants of the coronavirus are, we have the beta variant, the alpha, the mu, the gamma, and the delta variant, each of which will be discussed in this segment today.
Thank you very much, Dr. Tiffany. Now, Dr. Hines, we know that these variants originated from somewhere. Where were they first detected?
Thank you for having me today. So I know you might be hearing these terms and you're wondering what are they all about. So about the origins of these variants now. The alpha variant, also known as B117, it was first detected in the UK. This variant emerged with a large number of mutations. The spread of this variant greatly affected a surge of COVID-19 cases in the UK since November. The beta variant is another, and it is scientifically known as B1351, that was first detected in South Africa. The variant, just like the alpha variant, emerged with a large number of mutations in South Africa. As the variant spread faster than other earlier variants of the virus, the variant is responsible for the second wave of the pandemic in the country. The mu variant now is another variant, and it is also known as B1162. That variant is a variant of interest, and it is not as deadly as the delta. The mu variant was first detected in Colombia in January 2021. The delta variant now is scientifically known as B16172. The delta is highly contagious SARS-CoV-2 virus strain that was first identified in India in December 2020. Delta swept rapidly through that country and Great Britain before reaching the US, where it quickly surged. The gamma is another variant, and that variant was first detected in Brazil. It caused a widespread infection in the city of Manaus. As shown with Africa and UK variants, the Brazilian has shown enhanced transmissibility and it spreads globally. So far, no strong evidence of lethality of this variant, but more study is required. Yes.
Thank you very much, Dr. Javine Hines. So, Dr. Tiffany, out of all of these variants, which one is the most transmissible?
So, the Delta variant is considered a variant of concern by the Center of Disease Control because it appears to spread more easily from one person to another. This is so because this specific variant has mutations on its spike protein that makes it easier to infect human cells. So, with this being said, now we can conclude that if a person contracts the Delta variant, they can be more contagious and they can easily spread it to others. And those who are not vaccinated are more at risk. Now I have a diagram here that I want to show you. So this diagram here is showing the number of samples that are tested for each country and the percentage that came back positive for the Delta variant. And we can see here that for all the samples tested, we can see that a high percentage of the samples came back positive for the Delta variant.
Thank you very much, Dr. Tiffany and Dr. Hines, for that information. Now, we are going to look at the structural differences of these COVID-19 variants. And when we are talking about structure, we are talking how these variants are formed. First, we will take a look at the COVID-19 virus itself, then we look at each variant. So here we have a diagram of our COVID-19 virus. So as you can see here, this is our spike protein where most of the mutation occurs. This is our membrane protein, also known as the M protein, the envelope protein, which is also known as the E protein, the nucleocapsid protein, which is also known as the N protein, which surrounds the RNA. Okay, so now we will take a deeper look at the spike protein where most of the mutations occurs. Okay, so here we have our spike protein here. This is the header. And on it, I have the receptor binding domain. And this is the ACE2 angiotensin converting enzyme, which is found in humans. So this, the receptor binding domain, will bind to this enzyme here and enter our system. Okay, now we're going to look at the COVID-19 variants. The first one that we'll be looking at is the alpha variant, which is also known as B1.1.17. So the key mutation, it has 15 amino acid swaps and 3 amino acid deletion in the protein of the virus. 9 of these mutations occur in the spike protein, including N5101Y, which is a mutation that increased the binding affinity towards the human angiotensin converting enzyme receptor. A swap of asparagine, which is another protein amino acid, to triacin in the receptor binding domain, and a deletion of the 69, the 70, and 144 amino acid in the N terminal. The biological impact: the mutation in the spike work together to bind to the angiotensin converting enzyme 2 more likely, and they help the protein to hold on to ACE2 more tightly. Studies have shown that the virus is about 50 to 70% more infectious. Okay. Next variant that we can look at is beta, which is also known as B1351. So this mutation, it has 12 amino swaps in the protein of the virus compared to alpha, which have 15 amino acid swap. Beta have 12 amino swap in the virus of the protein. 9 of those swap occur in the S protein, again the spike protein, with 3 occurring in the receptor binding domain N501Y. The same swap is observed in the alpha K4179 swap of lysine to asparagine and E484K mutation. This helps the virus to escape the immune system. Then a switch of glutamine acid to lysine. The receptor binding domain of beta shows 3 states. Most were fully open with 1 or 2 receptor binding domain in the upper conformation. The structure was also solved without any fluorine cleavage, site substitution, or stabilizing tandem to confirm the unusual triple of the receptor binding domain up conformation. So the biological impact. The change in the spike protein seems to make the form of the spike in the receptor binding domain in the up position that was stated earlier more likely, but via a different mechanism from the one used by the B1.117 variant. Research has shown that This variant is up to 50% more infectious than the original virus. And now, Dr. Christine Richards will be sharing with us on the other variants of COVID-19. Dr. Christine Richards, over to you.
Hello everyone, I'm Dr. Riches, so I'll be continuing where my colleague left off as it relates to the structural differences of the coronavirus variants. I must add though that studies are ongoing as it relates to the structural differences of these variants. So I'll be presenting now on the Mu, Gamma, and the Delta variant. With the Mu variant, it has 21 amino acid mutations in its spike protein and 9 amino acid swaps. Even though it has 21 mutations, it is not considered as transmissible as the other variants. However, it is considered to be better at avoiding immunity to vaccines. The Gamma variant has 3 mutations. It is not as much as the other variants. It is not as transmissible as the other variants. It does not attach to the ACE of the human cells. The Delta variant, which has 15 amino acid swaps, and 1 deletion in the viral protein, is considered to be the most transmissible variant. It attaches easily to the ACE of human cell. It gets easily into the human cells and replicates easily in the human cells. I must also add that the spike protein mutations in these variants are what causes the mutations of the virus, and this is what gives the viruses their different genetic makeup. So for the Delta variant, its mutations will causes it is what causes to be to easily attach to the AC in the human cell to replicate easily and cause more infectivity as it relates to mutations.
Thank you very much, Dr. Christine Richards, for sharing with us on the structural difference of the COVID-19 variants. Okay, now we'll be taking a commercial break from our sponsor, MOH. Welcome back and thank you for joining. We are talking about comparative study of the COVID-19 variants. Earlier we spoke about the types of variants, which is the most transmissible variants, the origin of the variants, and the structural differences between the variants. Now we'll be looking at the signs and symptoms of these COVID-19 variants. And joining me is microbiologist Tamika Clark.
Good day, I am microbiologist Tamika Clark, and I will be discussing the differences in signs and symptoms of COVID-19 variant. According to CDC, all COVID-19 variants causes similar symptoms. Variants such as Alpha and Delta causes severe illnesses and even death. Most common COVID-19 variant symptoms include fever greater than or equal to 100 degrees Fahrenheit, cough, tiredness, fatigue, shortness of breath, sore throat, headache, and aches and pains. Symptoms of alpha variant include chills, loss of appetite, headache, and muscle ache. There is, however, no indication that symptoms of beta variants are any different from the other COVID-19 variants. Delta signs and symptoms include headache, sneezing, runny nose, and sore throat. Signs and symptoms of gamma variant include high temperature, cough, which is a persistent cough, and changes in taste or smell. More variants, signs and symptoms include muscle or body ache, cough, shortness of breath, sore throat, fatigue, nausea or vomiting, diarrhea, and chills and fever. Thank you.
Thank you very much, microbiologist Tamika Clark. Viewers, as you heard, these signs and symptoms can be mistaken for the common cold. So if you're having a cough, a high temperature, running up the nose, or sore throat, don't be afraid to get tested. Okay? Now we'll be looking at the infectivity and the disease causing of these COVID-19 variants. Joining me to discuss this is Dr. Tashima Williams Banks and Dr. Daisy Smith. Dr. Tashima, over to you.
Good evening, Dr. Campbell. Thank you for having me this evening. Now, in epidemiology, infectivity is defined as the ability for a pathogen to cause infection, while the disease causing would refer to the genetic alteration that would increase an individual's susceptibility or predisposes them to a certain disease. Now that we're speaking on the coronavirus, especially the Delta variant, which is the variant of concern at this moment. Now, before the virus infects a cell, the spike protein strand folds and it intertwines to make two conformations. The first conformation occurs in a down state in which the receptor binding domain is hidden. Now, the second conformation occur in an up state where the receptor binding domain faces and binds to the angiotensin converting enzymes, and that is how it latches onto the cell to infect a person. Now, persons who are infected with this Delta variant had viral loads up to 1,600 times higher than persons who were infected with the original. So, on an average, the variants are detected within 6 days after a person is being infected. With this Delta variant, it is just 4 days that you are able to detect this virus, to show you how much the virus is replicating very fastly. Hence, why it is recorded in 130 countries so far. So persons are asked to take precautions, especially those who are more at risk of catching this virus. So persons are asked to take precaution, wear your mask, sanitize your hand, ensure that your immune system is very active and up to date. So take all the necessary precautions.
Good day, Dr. Campbell, and good day, colleagues on the panel. Thank you for having me. Today is just a further discussion into infectivity and disease causing, just to expound on what my colleague had already said. It is an obvious thing that Delta variant is most transmittable than even the Alpha. And as such, persons are going to get sick easily and sick severely by the Delta variant. And the Delta variant, it causes more infection and spread faster than earlier forms of SARS, the virus that causes COVID-19. It is also spread more easily than previous variants. It also may causes more than 2 times as many infections. Persons who are prone to the Delta variant are, well, everyone is prone to the virus, whether you're vaccinated or unvaccinated. Because even though you're vaccinated, you practice precautions, and it's just that unvaccinated persons are more at risk, along with elderly persons and persons that have, such weak immune system. And even though we know a quite amount of information about the Delta variant, it is still in study. It's still an ongoing study, not just the Delta, but other variants as well. This is all I have to say, and I thank you very much for your invitation, and do enjoy the rest of your day.
Thank you very much, ladies, for joining us today to share on the comparative study of COVID-19 variants. I must say thank you to Dr. Williams Bent, Dr. Dacia, Dr. microbiologist Tamika Clark, Dr. Javine Hines, Dr. Tiffany Bassier, Dr. Christine Richards. Thank you for joining and sharing this information with us today. I hope you all have learned something new and take the necessary precaution to protect yourself and your family from this virus and its variants. Thank you for joining and see you next week.